Okay, so I would like to thank the organizer for giving me the opportunity to be here today. I am presenting a research that we carried out at the University of Granada in collaboration with the University of Burgos and the University of Vienna, and it focuses on gender identities in prehistoric societies of southeastern Iberia. To explore gender identities in past populations, bioarchaeology has become a particularly powerful tool. This is because, in addition to estimating biological sex, it allows us to link skeletal evidence to lived experience. The body preserves traces of repeated activities, and these traces become part of an individual's biography. By studying them, we can begin to understand how gender identities were constructed and embodied in everyday practices. One example of these traces is non-masticatory dental wear, which reflects the use of teeth as tools for processing of plant or animal fibers. When we combine this evidence with sex estimation, non-masticatory dental wear becomes a perfect indicator of gender roles. In the Iberian Peninsula, several cases have been documented in Bronze Age and Chalcolithic contexts, as you can see in these pictures. In most of these cases, good preservation allowed individuals to be sexed using traditional osteological methods. However, this in the megalithic cemeteries where I usually work, specifically Panoria and Los Milanes cemeteries in southern Iberia. In this context, the remains are poorly preserved and heavily commingled. Teeth are usually isolated and cannot be associated with individuals, making traditional sex estimation impossible. The aim of this study was to explore or evaluate the gender identities in Panoria and Los Milanes cemeteries by combining archaeological evidence, non-masticatory dental wear analysis, and biomolecular sex estimation. We analyzed 1,452 teeth, of which 16 showed clear evidence of non-masticatory dental wear. A crucial point is that except 2 teeth, all these teeth were isolated. And this means that they couldn't be linked to a specific skeleton, and therefore biological sex couldn't be determined osteologically. First, we conducted a macroscopic analysis to classify the teeth and describe the observed marks. Second, we performed a microscopic analysis using scanning electron microscopy to identify the group morphology. And finally, because osteological sex estimation wasn't possible, we applied peptide-based sex analysis. We calculate the minimum number of individuals of all these 16 teeth to ensure that the same individual was not sexed more than once. And a total of 10 teeth of these 16 belonging to 10 different individuals were analyzed, 7 from Panoria and 3 from Los Milanes. Here in this slide, you can see the 16 teeth with this atypical wear. In total, we recorded in these teeth 29 groups and 3 cases of polished enamel. The first aspect analyzed was the location of these marks. All groups were found in the anterior dentition on incisors and canines, with a clear predominance on incisors. Regarding laterality, 78% of the marks appeared consistently on right side teeth. Moreover, 91% were located on maxillary teeth. All of these suggest that these individuals primarily used their upper right anterior dentition for these activities. Also, 2 main group orientations were identified. First, a mesiodistal direction, meaning that fibers move from side to side across the tooth. And second, a labiolingual direction, indicating movement from front to back. These 2 orientations likely reflect different patterns of fiber manipulation. Another characteristic identified was the intensity of this activity. Of the 29 groups recorded, 21 penetrated completely through the enamel, exposing dentin. This indicates repeated and long-term activity, and additionally, polished enamel traditionally associated with leatherworking was observed. In our case, this enamel was worn away, again suggesting habitual and sustained use. Microscopic analysis revealed rounded group with smooth, polished walls and predominantly U-shaped cross-section. Microstriations were mostly thin and parallel, following the group axis. And all these characteristics are key for identifying the type of fibers involved in these activities. The peptide-based sex analysis successfully identified biological sex in all 10 individuals, 7 from Panoria and 3 from Los Milanes, and all of them female. To conclude, the evidence suggests that these women used primarily their upper right anterior dentition for fiber-related tasks. While the predominance of right side is high and Panoria and Los Milanes, other Iberian collections, such as the Argarians age, show different lateralization patterns, indicating variability influenced by different techniques or cultural practices. The depth and orientation of the groups reflect controlled, repetitive movements associated with fiber processing. Mesiodistal grooves suggest moistening and reinforcing fibers, while labiolingual grooves indicate pulling actions with the teeth functioning as gripping tools. And ethnographic parallels also support leatherworking activities using these teeth. The morphology of the groups and the fine microstriations suggest plant fibers, likely flax or hemp. Archaeological textile evidence from Chalcolithic and Bronze Age southeastern Iberia supports this interpretation. And to date, including these 10 individuals from Panoria and Los Milanes, 33 women have been documented in Iberia presenting this type of non-masticatory dental wear. This represents 94% of sexed individuals. This result strongly suggests that fiber processing and textile production were embedded within the female gender sphere. Women appear to have played a central role in textile production, an activity fundamental not only to domestic life, but also to the symbolic and economic systems of late prehistoric societies. And thank you very much for your attention.